All right, well, I'm going to go ahead and start some of the preliminaries. We do have people still joining us. So everyone, I want to welcome you to the Natural Area Association webinar. This is How Do Natural Areas Affect Financial Markets? And this is a very different topic for the NAA and for all of you, I am sure. However, it is one that's really important to all of us as we work to write grants, help to defend our programs, defend the funding of our programs, work with political and budget leaders. So we're excited that we are able to offer this information to you today. So before we get started, I'd just like to tell you a little bit about the Natural Areas Association. My name is Maura McGinty-Kloss, and I am the Director of Programs and Communications for the NAA. And the NAA is a national nonprofit organization that serves practitioners who manage ecologically significant landscapes to protect biodiversity. We supply applied science or applied programming in applied science, practical solutions, and knowledge transfer related to the management of natural areas. I just want to let everyone know that NAA has created an on-demand access to some of our programming that we have offered in recent months and years. It's called the NAA YouTube channel, and I know you've heard of YouTube. So if you're able to scan that QR code, you will go to our website and learn a lot more about upcoming programming, but also you can connect to our YouTube and subscribe, and you will have access to all kinds of conservation science, natural area science, and it's all sorted by topic. So we hope you find that helpful. So now I would like to introduce our speaker. So Claudio Rizzi is an incoming assistant professor at the Financial Management School Department, IESE Business School. He got his degree in finance from the University of Miami and a BS and MS in finance from Florida State University. His research focuses on sustainable and climate finance with a particular interest in the role of nature and biodiversity and loss on financial markets, firms, and household finances. His dissertation has received multiple awards, including the BlackRock Applied Research Award, the FIASI Gabelli School ESG competition, and the Best Paper Award at various conferences. He's presented at various leading conferences in finance, such as the United Nations Principles for Responsible Investment Academic Week, GRASFI, AFA, Financial Down Under, EFA, ARCS, etc. And his research has been featured in various media, such as the UN PRI blog and Network for Business Sustainability. And as a matter of fact, how NAA found Claudio's research from his Principles of Responsible Investment blog was posted earlier this year, and I'll put a link to that in the chat later for those of you who would like to read it if you haven't seen it already. So at this point, Claudio, I'm going to stop sharing. I'm going to let you take over.
Thank you so much, Maura, and thank you for the introduction, and thank you for the invitation to the NAA. It's a privilege to speak to this audience and also to have the opportunity to speak to somebody that's a little outside of the finance world and maybe has a much better understanding of how it is to handle with forests and natures and wetlands in real life. So I hope I can be of use with this presentation. And here you should be able to see my slides. And as Maura mentioned, I'll keep an eye on the Q&A so that I can address any doubts that are coming up during the presentation. Okay, let me make sure I'm set up. Perfect. Okay, so yes, as Maura introduced, this is my one of the chapters of my dissertation, Nature as a Defense from Disasters, Natural Capital, and Municipal Bond Yields. I did most of this work while being a Ph.D. at the University of Miami, and I will be joining IESE Business School in Barcelona this coming September. So of course, I don't need to convince you that climate change is really affecting us, both in ecosystem matter as well as in a matter of economy. And we see that natural disasters have increased in frequency and intensity due to global warming. Studies have shown that as the temperature increases, the atmosphere is able to hold more moisture, which in consequence increases the intensity and frequency of extreme rainfall. And here I just have two plots that help us put a picture on the increase in this magnitude and frequency of natural disasters. So we see how many more events are happening in the US and how more damaging those are. Most of them, as we see in green and yellow, are severe storms and tropical cyclones and hurricanes. So these that come with heavy precipitation are really damaging coastal areas as well as inland areas in the US. And as we know, and you know more than me, nature conservation and natural areas are extremely valuable and one of the most effective strategies to fight climate change and to mitigate the impact of especially a strong natural disaster. And we know that wetlands are extremely valuable at absorbing excess precipitation and avoiding flood damage. Forests also have a similar ecosystem service. So the soil acts as a sponge. And in coastal areas, especially close to Miami, where I did my PhD, is there is a very important ecosystem, which is forest mangroves, mangrove forest, excuse me. And these are extremely valuable also with storm surge. So we have all these various ecosystems and their service that mitigates extreme weather that has been found in the literature in environmental economics. So there's various studies that show this. Some examples come from the empirical evidence and some are more anecdotal, we see on a daily basis, but let's talk about the empirical side. In 2012, when Hurricane Sandy hit the northeast of the US, the study by Narayan et al. Shows that coastal wetlands were able to avoid an estimated $625 million in direct flood damages, 625 million. This is a quite large number, only and specifically due to coastal wetlands. Also, a very important study by Taylor and Drucker-Miller published quite recently in one of the most important journals in economics shows that also flood insurance claims are directly related to wetland loss. So more wetlands loss means that we are going to incur in much higher and more frequent claims and damage from flooding. So households and large firms will be affected by these increase both in the claims and also in the insurance cost. And as we've seen in the recent days, some states are even not able to insure households anymore. An example comes from California with wildfires, as well as some areas in Florida. From one side, we know that some states are even intervening and mitigating the risk of extreme weather and climate change using nature-based solutions, and in particular, nature conservation projects. So in 2022, there were some municipalities, actually some counties and states like New York and Cook County and Carbon County in Pennsylvania that passed measures to fund these projects that were basically nature-based solutions. So for flood mitigation, wildfire conservation, biodiversity preservation, and water pollution reduction. Some of these projects were quite costly. In fact, New York only by itself spent $4.2 billion on these nature-based solutions. So there is some interest at the local government level and at the state level for funding these nature conservation projects. So where do I come in? So in the literature in finance, we have focused a lot on how climate change risk and extreme weather affect financial markets, firms, and so forth. But we don't know much about how natural areas impact financial markets. An example can be municipal bonds, which is what I study in my paper. But in general, we don't know much about how nature and biodiversity affect firms and financial markets. The one main channel that I am envisioning that really affects financial markets is the mitigation of extreme weather and climate change. And I will look into municipal bonds to better empirically identify this effect. And I'll discuss this a little more. Also, with respect to the empirical approach, I exploit an exogenous geographic variation in upstream versus downstream wetlands that I'll also explain a little further later. This is adapting from an approach from Taylor and Drucker-Miller, the paper I mentioned earlier. And I also use a novel experiment that utilizes natural capital shocks together with extreme weather events. What I find is also, what I need to find also to understand is why municipal finances and financial markets would be affected by nature loss. And what I find is that the channel seems to be strictly related to extreme weather risk and local revenue risk. Again, I'll discuss these a little more soon. So I won't talk too much about the literature, but I wanted to point out, like I mentioned briefly, that finance has been taking seriously the issues of climate change by studying how municipal bonds are affected by sea level rise and extreme weather. And the insights seems to suggest that sea level rise impacts municipal bond yields. So it becomes more costly to borrow when you're exposed to sea level rise risk. Also, stocks and real estate have been shown to suffer from exposure to the risks related to climate change, as well as mortgages. Mortgages also quite clear since they're strictly related to an asset, the houses, that is directly exposed to the weather. So the paper that I have, on the other hand, the economics literature has also studied the importance of climate change and extreme weather. We have seen that nature can mitigate the damages of extreme weather. There's some studies that I mentioned earlier with the hurricanes, as well as the wetlands. And we also know from the economics literature that natural disasters will affect local economies in a very substantial and long-lasting way. Also, there is a recent paper in the finance world that actually tries to create a theoretical model to understand how mitigating disaster risk can affect tax revenue, economic growth, and so forth. And their insights is also going in the same direction as my paper. Defending ourselves and our economies from climate change is going to create future economic growth, as well as more tax revenue, and just protects our economies and make them more resilient. My paper comes in here in three major ways. So where do I see the contribution of my work? Again, as I mentioned, we don't know much how nature affects financial markets. And I try here to start the conversation and start the analysis on how nature loss affects financial markets and the borrowing cost of a very important entity, which is municipalities, counties, and states. Also, I propose an alternative way to measure how much natural capital is worth using a market-based financial estimate. Again, this is coming straight from the trading of municipal bonds and the information that investors are sharing. Also, since we know that global warming is not close to stopping, we need to understand even further the implication of it for local economies. So understanding how nature can protect us from economic losses can also help us better understand the local risk related to climate change and global warming. And this can be seen also as a study of how mitigation from climate change through nature-based solutions or conservation can help us in mitigating the economic risk of climate change. On the other side, we can also see this paper as showing how destructing nature or not protecting us from global warming and extreme weather can affect us in the long term with respect to our local economies as well as the nation's economy. Also, when you know better than me, like there is counties and municipalities always trying new development projects and so forth, but until now, the value of nature with respect to the financial savings of protecting it was not accounted when we think about new projects. So the losses from wetlands were, yes, accounted for, but there was a piece missing according to my analysis. So here, my approach would be helpful to even increase the value of nature conservation when comparing the trade-offs of urban development. So here comes the more technical part, but I'll make sure that it is clear, and hopefully, if you have any question, I'll address them immediately. So the core of the analysis here will be performed on municipal bonds. These municipal bonds are debt securities, so basically are loans that are issued by municipalities as well as counties and states to fund public projects. So we can think of schools, hospitals, highways, nature conservation initiatives. These bonds are loans that the municipality issues, and they use this money for these projects. There's two types, revenue and general obligation. The revenue bonds are usually supported by the revenue of the source of the project. So if there is a highway with toll, the tolls will be used to repay the bond. For general obligation, the general revenue comes from the issuing entity, so the tax revenue, basically, of the county. To understand who invests in these assets, I show here that 66% is held by household, ultimately, either directly or through mutual funds. The rest of the investors are institutional, sophisticated investors. The big difference between households and institutional investors is that households buy to hold for all their life. Institutional investor, on the other hand, trade on information. So the institutional investor might sell or buy different bonds around the US or around the state according to the level of risk that the institutional investor perceives. So the change in the price of these securities could be used to understand what's happening at the local level with respect to risk. So in the paper, I will mainly speak about changes in yields. So a municipal bond has a price, which is the amount that the worth of the loan. So if the municipality issues a bond of $1 million, it will receive $1 million. And the yield represents the interest rate. So for instance, if New York State issues a bond for nature conservation worth $1 million, has a yield, a coupon rate of 3%, the yield is going to be telling us the interest rate that the state will pay the loan for. So if you hold the bond, if you hold $1 million of this bond, you're going to get 3% interest on top of that $1 million at the end of the loan. So what does the yield tell us? The higher the yield, the more expensive it is to borrow. And this also means that the bond is riskier, is issued by some county that is a little riskier. We can think of this in the form of mortgages. So if you have a low score, a credit score, you will pay a much higher interest rate. Why? Because you're a riskier person to lend the money to. This is exactly the same for municipalities, which if they are riskier, they will have to pay more in interest when they lend money. So what I'm exactly looking at is the yields. So why these yields are going to be important? So first, municipalities cannot relocate, right? They need to rely on adaptation from extreme weather and climate change in order to respond to it. They cannot, like firms, change their headquarters of their production sites. For this reason, if I am the investor in a municipal bond, I will account for the local geographical risks when I am pricing these securities. So if I am deciding to invest in the bond from New York City, I will assess the local risk related to the economy, the geography, climate change risk, extreme weather, and so forth. That's why municipal bonds become really valuable in pricing climate change risk, extreme weather risk, any type of risk that is local. I won't go through the data too much. I see there's no question. Hopefully the municipal bond introduction was clear. But with respect to data, I use many sources that range from standard financial data on municipal bonds all the way to satellite data from Google Earth Engine that help me understand the local changes in wetlands as well as other natural areas and land cover. I also use the National Hydrography dataset to understand the water flow and distinguish between upstream and downstream areas. And this will be important for the identification strategy that I will discuss later. Of course, I use other data sets, but let me skip to the actual approach that I follow. So there's damages data, standard economic data, and weather and precipitation information. So the ecosystem that I focus on is wetlands. I also run tests of wetlands on wetlands and forests, but I focus on wetlands, as I mentioned earlier, for their ability in mitigating extreme weather and especially flood risk. So here there is a distribution of wetlands across the US. We can see they tend to be more prominent in the Southeast and the North, in wetter climates and close to river basins and rivers, and also close to the ocean, but they're quite spread out. This information comes from the National Land Cover Database, which is satellite sense data. In the US, we have 5.8% of the land area covered by wetlands. The rest is half in cropland and pasture, 2.6% in development, and 41% in other natural ecosystem and open waters. So there's still a relevant part of the land cover. So let me speak about how I'm able to figure out how much wetlands contribute to the risk of a local county. What do I start from the fact that wetlands absorb and collect water from precipitation. Then I also know that wetlands upstream, so if we see this picture here, can help us understand that the wetlands that are on this little hill are the ones that are protecting us from flood, because the water will go from upstream to downstream and flow through the little town that is drawn here. So the flood mitigation happens upstream. This identification strategy is valid if and only if urban development is not systematically biased towards upstream or downstream areas. So basically, a developer that comes in and chooses, does not have a bias from choosing to develop upstream of a county versus downstream. I run tests to make sure that this is not the case. So here, this is what I'm basically comparing. So before I show you the result, I'm comparing the change upstream versus the change downstream. So I'm able to control for local characteristics and local changes as well at the local level, at the county level. And then I compare, do changes in upstream affect municipal bond yields compared to downstream changes? If there is a difference in the yields, this means that the flood mitigation ability of wetlands is affecting the municipal bond yields of the county. What are the results? When I look at a 1 standard deviation change in wetlands, so when about 748 hectares of wetlands are lost, this is about 2.2 times New York Central Park in New York, of course. This large change is related to a change in municipal bond yields of 0.47%. How big is that 0.47%? That's 15% of an average bond yield. An average bond yield is about 3%. So if I destroy this large wetland upstream, my municipal bond yields are going to increase by 47 basis points. This is an enormous increase in cost. Specifically, if we go at the local level, this large loss would reflect into an increase in annual borrowing cost of about $4 million. This is for an average county. So this is when we look at the financial budget of these counties, it's 11% of interest expense. So adding 11% to an expense of a county can make a huge difference. $4 million is also about the cost of building a 2-mile highway that has 2 lanes going back and forth. So this is some money that the county won't be able to invest in this highway because there is some destruction of natural capital. So these are quite serious repercussions. Also, when we look at the investor side, so first we looked at the municipalities that are receiving the money. So those are that are borrowing money. What happens to their borrowing costs? There is also the other side of the coin, which is the investors. What happens to the investors? They lose about $6.3 billion related to this loss in wetlands. So when I look at all the wetlands that have been lost upstream of some counties, and I look at the change in the investors' portfolios, basically the price of these bonds, I see that their loss is about 6.3 billion. This is enormous. Also, something interesting that is consistent with the economics literature, I find that there is no change in yields for wetland gains. Why is that? This is because we found that wetlands take a long time to recover their flood mitigation abilities and their ecosystem services. So short-term gains in wetlands, so basically when crops and pasture land is converted into a wetland because it's let rest, we do not see this positive effect in the yields, or rather this negative effect, because the lower the yields, the better is for the county that is borrowing the money. So we do not see that at this stage. It's possible that these gains will be projected in a longer time period. Maybe it takes 40 to 50 years for the wetland to recover their real flood mitigation abilities. We don't have to have estimates at this time yet. So I see there is a quick question. Let me take a quick pause here before I get into the channels. Okay, so Andrea mentioned that what it means that the urban development is not systematically biased to upstream or downstream areas. So if we look at a county and there is an urban developer that is looking to start to build an apartment complex, the fact that among his criteria for choosing a specific plot, there is no consideration related of being upstream of a wetland or downstream from a wetland. So basically, the developer is not looking at the geographic composition of the area upstream and downstream from where he wants to build to figure out if it's going to build in this area versus another area. So there is other consideration, of course, that the developer will have, but at this stage, there is no evidence that they are looking, both anecdotal from speaking to them, as well as from the data, that they are looking at the upstream wetlands and downstream wetlands, or where they want to build, upstream from a wetland or downstream from a wetland. I hope I was able to clarify that part. So in order to clarify what's happening with the municipal bond yields, I need to figure out why is the yields related to nature loss. So again, we have established in the economics literature, environmental economics literature, and also in the biology literature, that wetlands mitigate extreme precipitation and flood damage. There's a lot of evidence of that. I go and build upon this knowledge and find that flood risk is directly related to wetland loss. So when a wetland upstream is lost, I find that extreme weather risk at the local level, at the county, increases. Why can I say that? I'll discuss that in a second. Also, I find that the cash flow risk channel is important when we're thinking about why municipal bond yields are changing. For cash flow risk, I mean tax revenue. Is tax revenue for municipalities affected by changes in wetlands? And the answer is yes. What I find is that counties that are more reliant on local tax revenue compared to state or federal funding see the highest increase in bond yields related to the wetlands loss. So as I mentioned earlier, this Taylor and Druckenmiller paper is quite relevant here, and I encourage you also to utilize it or to read it when you're in the need of evidence related to how wetlands can be really impactful in decreasing damage. So what they find is that there is quite large increase for each hectare of wetland loss between $1,800 and $8,000 in flood insurance claims, more flood insurance claims. It's quite large for just 1 hectare. This $8,000 value that you see is when wetlands transition from wetlands to developed area. So an apartment complex, a factory, and so forth. So of course, putting cement on a wetland would create the most damage. This is quite trivial. Maybe not for everybody that are starting these projects, but for environmental scientists, it should be clear. Of course, I have to confirm that this is the case. I also find similar insights related to weather damages, not only flood insurance claims. So when 1 hectare of upstream wetlands is lost, weather damages increase by $13,000. So it's quite large increase. For the same magnitude that I discussed before, the 2.2 times New York Central Park, the increase in damages is of about $10 million. So here, we also see the direct impact of wetlands loss. So this is what the one of the channels that seems to connect wetlands to bond yields, the increase in local extreme weather risk. The other channel that seems to be important here, especially when we're thinking about finance, is that the funding of the county or the municipality should be relevant, because if the county is receiving most of the money to fund their budget from the federal government, then changing the local geography will not change the risk of the cash flows or the tax revenue of this local county. That is why when I look at different levels of reliance on local tax revenue, so basically counties that are more reliant on local sales tax, local property tax, and other local taxes, see the highest increase in yields. This is what you see also from the plot. The being more on the left means that the increase in yields is higher for the county compared to the ones that are not really reliant to local tax flow, local revenue, that are almost not affected by this change. I see, I'll address the Grazia's question in a second. Let me, since it's more, actually, let me take a minute to address that. So picking up, she says, picking up on the point of the systematically development on upstream or downstream wetlands, your recommendation would be that developers, city council, etc., favors development in upstream areas. Actually, the opposite. Well, it depends. The upstream, downstream can be confusing at times, but I think you have the right idea. So if some development needs to happen, if we are destroying upstream wetlands, we're going to see more damage for everything that is downstream from this county. So if one county is close to a wetland upstream and they do destroy the wetland upstream, they're going to see much more damages. So of course, somebody is always going to be downstream from somebody else. So it becomes more difficult to choose where, but we need to understand that there are some repercussions from developing these wetlands for whoever is downstream from that wetland. So it is difficult to actually state where to build, because of course, if we build, even local wetlands are valuable. Here I'm talking about upstream and downstream for identification purposes. Local changes can be related to other economic circumstances, so they might bring some endogeneity, some difficulties in the identification. So I'm focusing on the upstream, downstream for an empirical reason. Okay. I'm sorry for my voice is a little struggling, but I'm struggling with my voice a little bit, but I'll make it through the end. So when I look at very other differences across geographies and economies in the US, I find very interesting patterns. For instance, as I mentioned before, when we destroy wetland to turn it into an apartment complex, we're going to see the strongest impacts on the yields. So yields are going to increase more if we put cement on these wetlands. The damage is still significant when we put croplands and pasture instead of wetlands, but of course, the the soil can absorb still some of the water, so the effect is smaller, but still, there is some damage. Also, something interesting, more for a financial perspective, is that the yields increase almost only when there is an extreme precipitation event. So what this means when we look at the finance literature is that the pricing of the risk, so when do investors change their mind and affect the yields on these bonds? When does this happen? This happens only when extreme precipitation events happen, not when nature is lost. What does this mean? It means that investors don't really understand the value of wetlands and natural ecosystems when they're pricing these securities. I find this evidence both in the empirical data as well as in anecdotal evidence. So speaking to municipal bond investors and investment bankers and so forth, they mentioned that they don't look at wetlands upstream or local wetlands as a criteria that helps them understand what is the risk of a local community. So they're still not accounting for this risk, but when do they experience, when the county experiences this larger weather damages, the importance of these areas implicitly becomes salient to them, and that's when the change in the yields happen. So this is quite important for a finance standpoint, maybe not so much for for environmental science purpose, but it's interesting to show in the data that they actually don't fully understand the power of nature and the wetland ecosystems and how this can have, destructing them can have effects on the local municipalities and their pockets when we're thinking about returns on portfolios. But when the damages become salient, they update their belief on the risk, on the local risk, and that's when the yields change. Also, it's quite interesting finding was, and also somewhat trivial, is that farming communities see the highest increase in yields. So these communities are more reliant on the weather, and their revenue of the county is also strictly related to the farming that is happening in the county itself. So it makes sense that these should suffer higher increase in yields, and this is what I find. This could also be related to the threat to the broader food supply, because farming is really concentrated in the US. If the county becomes more risky, it is harder to fund projects. So it might be not worth for some investor to invest in these loans because it's too risky. And that, by consequence, does not create services for these local communities that could push some people to migrate or move somewhere else and not really farm these areas because they become too risky. Lastly, also, as probably you would have guessed, areas that are more exposed to more frequent intense precipitation see the highest increase in yields, up to 3 times. So if we saw that the increase in interest expense was $4 million on average, for these counties can be up to $12 million. So this is almost 33% of the interest expense on an annual basis, and this is enormous. Of course, they might mitigate this increase with FEMA funding, but this still means that there is quite large increase in cost for a county related to how they protect nature around it. Okay, let me also take this other question. So Betsy mentions that, are you also been able to see and quantify the correlation between loss of land that is not wetland and risk borrowing costs? That's quite an important question. Betsy, thank you for that. Basically, I don't have the time to address in the short presentation, but I look at also wetlands and forest. So forest change, I also looked at the forest change with the satellite imagery data, and I find that the forests also have positive effects in the sense that they're helpful in mitigating the increase in bond yields, but they're not as strong as the wetlands. So the forests are also valuable ecosystems. Also, I'm not trying to rank them and stuff in the sense that one is more valuable than the other. In this case, I'm speaking of flood mitigation and how this affects the bond yields, but maybe other areas might have other ecosystem services that are quite important, like biodiversity preservation, just carbon capture and so forth. So in this case, I do look at also a forest, and I find that they have some importance. Also, interestingly, this brings me to another point that when I look at changes that are of wetlands to other natural ecosystems, so just if the ecosystem is changing from a wetland, for instance, to open water, those wetlands are really susceptible to change from water, open water back and forth. These changes do not affect yields. This makes sense because the mitigation from flood risk is not being affected. So this is what I was discussing briefly related to the pricing of these wetlands when it's happening. This is important more for a finance standpoint because it tells us that investors are not sophisticated enough at this stage, or at least they're not caring too much about nature with respect to how it decreases flood risk, but they're still responding by pricing this risk when extreme weather happens. So this is where I'm trying to put a finger on with this analysis. So I see that I'll try to look at when nature capital is lost and what happens when this happens, when the nature capital is lost, and if there is any response in the yields, or if there isn't, why is that the case, or when will the response be in the yields? Because I already established, or at least there is some evidence here, that the yields do change when wetlands are lost, but I don't know when, because I'm looking at long time periods. So let me also highlight that the satellite data is quite valuable, but it's collected every 5 years. But the long time period that I'm observing here is from 2001 to 2016. So I look at the long change over these 15 years. So across this long change, I see that when wetlands are lost, yields increase, but I don't know exactly when this happens. So that's where my analysis comes in the first part. And then the second part is kind of addressing the when. That's why that I should have specified earlier that the time period that I'm looking at is a long difference between 2016 and 2001 to really make sure that the change in the ecosystem is real. And this is also standard for the environmental economics literature. So for the when analysis, I look at the changes in wetlands, and then I focus on a flood. So when there is a flood, like I show here again, this picture, what happens in the yield? So I basically look at every month, what happens to the yield related to the change in wetlands. What I find is that wetlands do not affect the yields in the period before the extreme, the flood, but when the flood hits, you see this decrease in the graph, the yields are changing when the flood happens. Basically, investors are not pricing and are evaluating ecosystems. Let me take that back. So what happens when the flood hits? The yields go down. This is because the investors see the additional damage that the county is experiencing. They're not pricing directly the wetland lost. They're pricing the additional damages. Because if they priced or they understood the risk of destroying the wetland, they would have seen the increase earlier. And here we would have not seen a change in the graph. It would be just stable, right? So that's what this analysis is telling us. So there is no effect when the nature is lost. I find no evidence with various types of experiments that look at nature loss events. And there's no response in the municipal bond markets. So this is something that I've specified. Investors implicitly value nature. They're not directly pricing the risk of destroying it. So this paper is quite long. It takes a look at very different aspects, given that it's also part of my dissertation, so it's a little long, but what I just mentioned other findings. So credit ratings are also affected, offering yields, which are the yields that are charged to the county and the municipality when they're issuing the bonds in the first place. Also, infrastructure projects or bonds issued for infrastructure projects see the highest increase. This is possibly due to their direct exposure to infrastructure destruction. Also, the effects on the yields seems to increase a little bit over time. This is relevant. This is consistent with the literature in finance that sees that investors are becoming more aware about the risk of extreme weather and climate change risks. So the yields increase more over time. And I ran very robust battery of tests to make sure that the results are stable and they're really driven by changes in wetlands, upstream versus downstream, many robust tests. So to conclude here, I've discussed how nature, and you know better than me, how it is quite valuable for mitigating extreme weather. But what we didn't know, at least till this paper and some other studies that are related to more the damages, what I find is that local natural capital and local nature ecosystems can help us decrease borrowing costs. They have a direct financial impact on these municipalities. This is strictly related to these services that the nature provides related to flood risk mitigation and other extreme weather mitigation. So the study, if you want to take it in one word, it tries to get to one of the many financial consequences that natural loss can have on financial markets. And one is related to the borrowing cost of municipalities. So this should be relevant to policymakers. Of course, I was lucky enough to present this work around the world, and especially via Zoom, to many important outlets. And it seems to really resonate with both the policymaker and firms. And they understand that this should be nature loss and biodiversity loss is important and needs to be really addressed across the board. One reason why this should be important is that the financial implication of it is quite clear, at least from this study, that there is going to be an increase in borrowing costs. The studies show there is going to be an increase in insurance costs, damages, household insurance claims, and you name it, there is going to be multiple effects. So they should be accounted for when we're thinking about new development of these natural areas. Also, just to conclude here, my research is around the sustainability and climate change risk, but I focus really strongly on the value of nature in a financial matter. And these new bonds, the green bonds, can be a good way to promote nature-based solutions, both at the firm level and at the municipal level or state, because they attract investors that are environmentally conscious. They are growing in size. They are quite large institutional investors that really care about environmental sustainability. So these issuing more of these bonds that fund projects that are related to nature conservation can be a good way to transition to a more green future. Related also to my research, I'm still studying how household finances, so labor income, insurance costs, real estate prices that they hold are impacted from losses and gains in nature. Also, I am looking at how biodiversity can affect firms, how they are dependent on biodiversity, and also how they impact biodiversity by their emissions and their corporate behaviors. Lastly, another study among many that I'm looking at are related to the drivers and constraints of investment in adaptation, nature, and conservation. So why these firms are choosing to do so, these communities. So I really thank you for the questions, and I'll take more if you have any, and I really appreciate your time. Thank you.
So I don't see any more questions. If you do have some, please feel free to pop them in. I see some applause coming up. There you go, Claudio. It's a tough topic, and but you did make it very understandable, and we really appreciate that. There is a lot of interest in the Taylor and Druckenmiller paper. I was able to find it on AEA's site. However, yes, some people had to, if they have institutional access, could see the full paper, others could not. And we also will, provide Claudio's email. He is very happy to, if you have a question after that, or, maybe you're writing a grant or trying to argue in your local community that they should be considering natural areas and the natural services that these vital ecosystems provide when they plan building sites, let him know, and I'm sure he'd be happy to, respond to your question. I do see a couple questions, so we got a couple minutes, so let's ask those. So, are there good examples where markets are supporting conservation? That's an interesting question.
Yes, there is many. The financial system is developing with respect to funding and providing securities that are funding projects that can go from nature conservation. So there is the ones that I mentioned with New York State and so forth, through municipal bonds, all the way to conservation bonds that basically are bonds utilized to protect the rhinos in Africa. I don't remember exactly. I think it was in Kenya. So these securities are utilized to protect specific ecosystem. And I can provide more examples via email if I think it was Sabrina that she would like, and I can share more details.
Okay. And then we have a question from Gavin. I am at an institution that preserves many, many acres of wetlands. I am curious about the application of this information on the calculation of the economic impact to nearby towns. Has a tool set been developed, or is this kind of where your work is leading?
Yes, it's a good point. The study itself provides a useful model to understand how market-based responses can help us price the value of nature. So what I basically do is I look at the data in the financial markets, and then using a model, I find these increases in yields that are related to the value of nature with respect to the municipality. So there is not a tool that is available, but if you can take the paper as a little maybe complex tool to actually price these effects. I can definitely work and maybe collaborate with somebody that has experience more on the field to see if we can maybe create a website where you can put the data on your wetlands, or maybe just the data where you are, and understand how the wetland is really affecting your financial risk.
So there you go. You've got a lot of practitioners here, and maybe somebody will take you up on that offer and say, hey, I would like to work with you. So that could be really important work. So thank you. I do not see any more questions coming in, so I think we will go ahead and wrap up. But thank you so much for this presentation today. As somebody said, it's a tough topic. It's not necessarily the types of science that everyone is used to working in, but it's important, and it's starting to lay out these important arguments that people who are, outside of the actual conservation space can really, to get funding to change some of the decision making that's going on around where development is happening. So thank you so much, everybody. You will be getting access to resources after this. So thank you, Claudio, and we look forward to maybe hearing from you soon, and maybe we'll see a tool. So thank you so much. Take care.
Thank you. Thank you so much.
Bye-bye, everybody.